presence of 10 volts at a lighting outlet when the switch is off is likely due to what is known as stray voltage, also called phantom voltage. This is a small amount of voltage that can be present in electrical systems even when the circuit is de-energized. Stray voltage can occur for several reasons. Firstly, capacitive coupling. Electrical cables can act as capacitors, storing a small amount of electrical charge. When the circuit is turned off, this charge can slowly discharge, creating a small voltage at the outlet. Secondly, inductive coupling can contribute. When an inductive load, such as a motor or transformer, is turned off, it can create a surge of voltage that can travel through the electrical system and appear at other outlets. Thirdly, ground loops can be a factor. If there is a difference in electrical potential between 2 points in the electrical system, a ground loop can be created. This can allow current to flow through the grounding system and appear as voltage at outlets. In most cases, stray voltage is not harmful and does not pose a safety hazard. However, it can sometimes cause problems with sensitive electronic equipment. There are a few things that can be done to reduce stray voltage. One is to use shielded cables. Shielded cables can help to reduce capacitive and inductive coupling. Another is to install isolation transformers. Isolation transformers can help to isolate different parts of the electrical system and reduce ground loops. Proper grounding of the electrical system is also crucial. Proper grounding can help to prevent ground loops and reduce stray voltage. When addressing this situation, it is important to note that 10 volts of stray voltage is likely not a major problem. However, if there are problems with sensitive electronic equipment, steps can be taken to reduce stray voltage. Here's a more in-depth look at the causes and solutions. Capacitive coupling occurs when two conductors are close to each other and separated by an insulator, forming a capacitor. In electrical wiring, the conductors are the wires themselves and the insulator is the wire insulation. When voltage is applied to one conductor, it induces a voltage in the other conductor, even if there is no direct electrical connection. This induced voltage is what we call capacitive coupling. The amount of voltage induced depends on several factors, including the distance between the conductors, the size of the conductors, and the frequency of the voltage. In general, the closer the conductors, the larger the conductors, and the higher the frequency, the greater the capacitive coupling. Inductive coupling occurs when two conductors are close to each other and a changing magnetic field is present. In electrical wiring, the conductors are the wires themselves and the changing magnetic field is created by alternating current flowing through a nearby wire. When a changing magnetic field is present, it induces a voltage in the other conductor, even if there is no direct electrical connection. This induced voltage is what we call inductive coupling. The amount of voltage induced depends on several factors, including the distance between the conductors, the size of the conductors, the frequency of the current, and the amount of current flowing through the nearby wire. In general, the closer the conductors, the larger the conductors, the higher the frequency, and the greater the current, the greater the inductive coupling. Ground loops occur when there are multiple ground paths in an electrical system. This can happen when equipment is connected to different ground points that have different electrical potentials. When there are multiple ground paths, current can flow through the grounding system, creating a voltage drop. This voltage drop can then appear as voltage at outlets and other equipment. Ground loops can cause a variety of problems, including noise in audio and video equipment, data errors in computer systems, and even electric shock. To prevent ground loops, it is important to ensure that all equipment is connected to a single, common ground point. This can be achieved by using a star grounding system, where all equipment is connected to a central ground point. Shielded cables are designed to reduce capacitive and inductive coupling. They consist of a conductor surrounded by a layer of shielding material, such as braided copper or aluminum foil. The shielding material is connected to ground, which helps to block electromagnetic interference from reaching the conductor. Isolation transformers are designed to isolate different parts of an electrical system from each other. They consist of two windings that are electrically isolated from each other. When voltage is applied to one winding, it induces a voltage in the other winding, but there is no direct electrical connection between the two windings. This isolation helps to prevent ground loops and other electrical problems. Proper grounding is essential for safety and performance in electrical systems. Grounding provides a low impedance path for fault current to flow back to the source, which helps to protect people and equipment from electric shock. Grounding also helps to reduce noise and interference in electrical systems. The NEC, or National Electrical Code, provides detailed requirements for grounding electrical systems. These requirements cover everything from the size of grounding conductors to the location of ground electrodes. Some common grounding methods include using a ground rod, a ground plate, or a metal water pipe as a ground electrode. The choice of grounding method depends on the specific application and local regulations. When dealing with sensitive electronic equipment, it may be necessary to take additional steps to reduce stray voltage. This may include using power conditioners, surge suppressors, or other specialized equipment. Power conditioners are designed to filter out noise and other electrical disturbances from the power line. Surge suppressors are designed to protect equipment from voltage spikes and surges. If there is persistent trouble, consulting with a qualified electrician or electrical engineer is recommended. They can assess the electrical system and recommend the best course of action. They will be able to properly assess the wiring and determine the extent of any potential problems. They can perform a more thorough investigation of the electrical system, including testing for ground faults, voltage drops, and other electrical problems. They can also provide advice on how to reduce stray voltage and improve the overall performance of the electrical system. Remember that electrical work can be dangerous, so it is important to take precautions to protect yourself from electric shock. Always turn off the power to the circuit before working on it and use appropriate safety equipment such as insulated gloves and tools. If one is not comfortable working with electricity, hiring a qualified electrician is always the safest option. There are different types of shielded cables available, each with its own advantages and disadvantages. Some common types of shielded cables include braided shielded cables, foil shielded cables, and combination shielded cables. Braided shielded cables offer excellent shielding performance and are very durable. They consist of a conductor surrounded by a layer of braided metal wires. Foil shielded cables are less expensive than braided shielded cables, but they do not offer as much shielding performance. They consist of a conductor surrounded by a layer of aluminum foil. Combination shielded cables combine the features of braided shielded cables and foil shielded cables. They consist of a conductor surrounded by a layer of braided metal wires and a layer of aluminum foil. There are also different types of isolation transformers available, each with its own advantages and disadvantages. Some common types of isolation transformers include single-phase isolation transformers, three-phase isolation transformers, and medical-grade isolation transformers. Single-phase isolation transformers are used in single-phase electrical systems. Three-phase isolation transformers are used in three-phase electrical systems. Medical-grade isolation transformers are used in hospitals and other medical facilities to protect patients from electric shock. There are a number of different grounding methods that can be used, each with its own advantages and disadvantages. Some common grounding methods include using a ground rod, a ground plate, a metal water pipe, or a concrete encased electrode as a ground electrode. A ground rod is a metal rod that is driven into the ground. A ground plate is a metal plate that is buried in the ground. A metal water pipe can be used as a ground electrode if it is in direct contact with the earth for at least 10 feet. A concrete encased electrode is a metal conductor that is encased in concrete. The NEC specifies the minimum size of grounding conductors based on the size of the service entrance conductors. The NEC also specifies the location of ground electrodes. Ground electrodes must be located as close as possible to the service entrance. When selecting a grounding method, it is important to consider the soil conditions, the local regulations, and the specific application. In areas with high soil resistivity, it may be necessary to use multiple ground electrodes to achieve adequate grounding. Local regulations may also specify the type of grounding method that is required. Always consult with a qualified electrician or electrical engineer to ensure that the grounding system meets all applicable requirements. When dealing with sensitive electronic equipment, it is important to use high-quality power conditioners and surge suppressors. Power conditioners can help to filter out noise and other electrical disturbances from the power line. Surge suppressors can help to protect equipment from voltage spikes and surges. It is also important to ensure that the equipment is properly grounded. If the equipment is not properly grounded, it may be more susceptible to damage from electrical disturbances. When troubleshooting electrical problems, it is important to use a systematic approach. Start by checking the basics, such as the circuit breakers and fuses. Then check the wiring for loose connections or damaged insulation. If you are unable to find the problem, consult with a qualified electrician or electrical engineer. Remember that electrical work can be dangerous, so it is important to take precautions to protect yourself from electric shock. Always turn off the power to the circuit before working on it and use appropriate safety equipment, such as insulated gloves and tools. If one is not comfortable working with electricity, hiring a qualified electrician is always the safest option. Stray voltage is a common phenomenon in electrical systems. While it is not always a cause for concern, it is important to understand the causes of stray voltage and how to reduce it. By taking the appropriate steps, one can minimize the risk of electrical problems and ensure the safe and reliable operation of electrical equipment. Grounding is a critical aspect of electrical safety and system performance. Proper grounding helps to protect people from electric shock, reduce noise and interference, and prevent damage to equipment. Adhering to the NEC guidelines for grounding is essential for ensuring a safe and reliable electrical system. When dealing with sensitive electronic equipment, it is especially important to take steps to reduce stray voltage and ensure proper grounding. Using shielded cables, isolation transformers, and high-quality power conditioners and surge suppressors can help to protect equipment from electrical disturbances. If there are persistent electrical problems, consulting with a qualified electrician or electrical engineer is always a good idea. They can assess the electrical system and recommend the best course of action. They can also perform a thorough inspection of the wiring and identify any potential hazards. Remember that electrical work can be dangerous, so it is important to take precautions to protect yourself from electric shock. Always turn off the power to the circuit before working on it and use appropriate safety equipment, such as insulated gloves and tools. Electrical systems are designed with safety as a paramount concern. Understanding the principles of grounding, overcurrent protection, and safe work practices is essential for anyone working with or around electricity. The NEC provides a comprehensive set of guidelines for electrical installations, and it is important to follow these guidelines to ensure a safe and reliable electrical system. Stray voltage, also known as phantom voltage or ghost voltage, is a common phenomenon in electrical wiring. It is a small voltage that can be measured in a circuit even when the circuit is supposedly turned off. This voltage is usually not dangerous, but it can be a nuisance and can sometimes cause problems with sensitive electronic equipment. There are several reasons why stray voltage can occur. One reason is capacitive coupling, where the wires in a circuit act like capacitors and store a small amount of electrical charge. Another reason is inductive coupling, where the magnetic field from a nearby energized wire induces a voltage in the de-energized wire. A third reason is ground loops, where there are multiple paths to ground, creating a small voltage difference between different points in the grounding system. Stray voltage is typically measured with a high impedance voltmeter. A low impedance voltmeter will load down the circuit and may not show the stray voltage. The level of stray voltage can vary depending on the wiring, the proximity to energized wires, and the grounding system. In most cases, stray voltage is not harmful and does not pose a safety hazard. However, it can sometimes cause problems with sensitive electronic equipment, such as flickering lights, buzzing sounds, or data errors. If stray voltage is causing problems, there are several things that can be done to reduce it. One is to use shielded cables, which can help to reduce capacitive and inductive coupling. Another is to install isolation transformers, which can help to isolate different parts of the electrical system and reduce ground loops. A third is to improve the grounding system, which can help to reduce the voltage difference between different points in the grounding system. It is important to note that stray voltage is not always a sign of a problem. In many cases, it is simply a normal phenomenon that occurs in electrical wiring. However, if stray voltage is causing problems, it is important to take steps to reduce it. If one is not comfortable working with electricity, hiring a qualified electrician is always the safest option. The electrician can assess the electrical system, identify the source of the stray voltage, and recommend the best course of action.